We are continuing in our converting. So last class we just did converting to standard form, which again I told you was kind of the easiest of all the conversions because it's really going forward. You're just multiplying everything out. The next 2 days, hopefully today is not anything like super crazy because you have factored before, I promise. But we're going to cover all types of factoring. So we're covering a lot of material. I also have a method that I factor with that I want to explain to you. It is not the only one available, but I do, at some point you are going to have to learn my method, so why not today? And then next class is also something that's probably brand new to a lot of you. So the next 2 days are kind of a little more intense, definitely practice heavy. You need to be keeping up with your practice packet and those problems. And then next week is review and test, okay? So kind of keep all that in the back of your mind. Here's where we are. Okay? If your screen is out, it needs to be closed now. We're on page 15. Also, retitle this. It says, I think we might have done this in here. It says 4.3. It should be 4.4. So, in the practice packet, you should be through 4.3. Should be. If you're not, you're behind. And you've got more problems starting today. Okay? So today is all about how to convert from standard form to factored form. So last class we focused on getting to standard from factored. Okay, close your computer, please. And then now we are going from no parentheses to how many parentheses? To 2 sets of parentheses. I've said this time and time again, but I'm going to say it one more time. This skill, factoring, it is not going away whatsoever. Next unit, we will solve by factoring. The next units from literally here until May 17th, the last day of school. You're going to have to do factoring all year long. It is really the one thing, if you sit down and talk to every math teacher from Algebra 1 on, they will all say, this is a skill that, keeps coming up. Y'all did it in geometry, right? Factoring trinomials? Okay. So you should have. But again, we're doing basically an entire unit in Algebra 1. We're going to do it in 1 day. So here we go. I'm going to get started. We're going to start the first day. It's fine. It's a review. We're going to start the first page with factoring binomials. Okay? Oh my God. Okay, here's what we're doing. Back to where we were. So this page, I started writing. What was I writing? Go put your phone out. If you took your phone to the fire drill, go put it up. You don't need your phone for the fire drill. Okay? This page, we have ground to cover, is about factoring binomials. Okay? On the first page, we're going to get to trinomials, which is mostly where we're going to be. But before we get there, we need to know how to factor a binomial, especially if we're going to factor with my method, as you all should. What's a binomial? How many terms? 2. 2 terms. So these are going to be set up something plus or minus something. So 2 terms. That's important because I will use this vocabulary quite a bit. Binomials versus trinomials. Okay? So our first little section is all binomials, and it's specifically about factoring out your GCF. What does GCF stand for?
Greatest common factor.
Good. So we have heard that before. Greatest common factor. And we have already been doing this in transformations when I'm factor out the B, factor out the B. Over and over and over again. It's reverse distributing. You're dividing. You're finding what the GCF is. You're putting it in the front, and you're dividing each term by that. Now, it's going to get a little more advanced than just taking out a number. We are going to be taking out letters sometimes, numbers and letters, all the things. This is always your first step when you're factoring anything. Check for a GCF, because if it has one, we want to take it out. Okay? So, I will do 1, 3, and 5, and then you guys are going to try 2, 4, and 6. So we're going to go quick because these aren't super long. What is the GCF on number 1? 2. Can you take out an X in this binomial? When can you take out an X? They all have it. Very good. Good. Okay, so your GCF goes in the front, and then you are dividing, and I'm going to write actually what I'm dividing by so you know where these numbers are coming from, and you're dividing by your GCF. So 2x divided by 2 leaves me with x. 4 divided by 2 leaves me with 2. And how do you check and make sure you did it right? Multiply it back in. That's where you should you should end up where you started. Okay, but this is our factored form, just taking out that GCF. And then we're done because I can't do anything else with x plus 2. Okay? All right, number 3. What is our GCF on number 3?
4.
Not 4. 2x. Okay, listen to what I'm about to say. The GCF, listen to me. The GCF cannot be bigger than the smallest number. So the smallest number here is 2, which means that's like the biggest the GCF can be. But 2 is divisible by 2, 8 is divisible by 2. They both have an x. You take out the lowest power when it comes to taking out x's. So x to the 2 versus x to the 1. The lower one is x to the 1. I'm going to do some throwback exponent rules for you. So your GCF always goes in the front. You don't have to put the 1, 2x to the 1, but I'm going to write it in my division. Do y'all know what you do in exponent rule land when you divide with exponents? You subtract them, okay? And so if you think about it that way, with the coefficients, you just divide. 2 divided by 2 is 1. You don't have to write coefficient of 1. X squared divided by x, 2 minus 1 is 1. So this is really x to the 1, but you don't have to put that there. Plus, 8 divided by 2 is 4. X divided by x becomes x to the 0, which is 1. Okay? And so there's what's left over as well. And y'all will get good at taking out x's and stuff, but I just kind of want to explain like why that stuff is happening from there. Okay? I don't even think I need to do 5. Do the other ones. Ready, set, go. Here we go. I'm going to unfreeze for you to check and see. Again, I like to write to the side what my GCF is. You don't have to do that. Really, it's just the box is your answer. Things to be careful for. On number 5, I'm going to come back to this problem in a minute and talk about it. But here's something that sometimes people forget to do. When your second term is your GCF, so like 4x is my GCF, people will forget to like put that actual number there. Like when you're dividing by 4x, if you factor out a GCF from a binomial, your answer should be GCF and then still a binomial because you're doing 2 divisions in there. A lot of times people will just be like, oh, that just cancels out, goes away. No. It is canceling, it's simplifying to 1. You have to actually put that 1 placeholder there. So that one sometimes gets missed, and there's another thing about that, which I'm going to circle back to. The other one, 6, did y'all do okay with that numeric GCF? Why is it 3? Because everything can divide by 3. That's the greatest it can divide by. I always start with the smaller number, but 15 is not divisible by 12. So then I just work my way down my factors of 12. 6. 15 isn't divisible by 6. Go to 3. 15 is divisible by 3. Boom. There it is. Okay? So again, this is a big deal being able to do this, and this is always our first step is checking for a GCF. The other binomial that we're going to look at is we check for this first. If we can't have, or if we don't have one, or even if we do, and we're left with a binomial, we always have to keep checking and seeing, can this binomial factor even more? All of these are done. They get to where it's just like x plus or minus a number. There's nothing else you can do. However, in these situations right here, this is our difference of squares pattern. Your binomials have a squared term in them. Even though there's only 2 terms. So this is kind of going to like throw you into a different factoring category. It's a pattern. Have you guys seen this pattern before? The A's and B's? Yes? No? Okay. So this factoring pattern, you don't have to memorize it. I'm going to kind of talk you through how I think about it. This is my favorite factoring pattern, like of all time. And we put this on a lot of stuff, especially in the winter when we get to rationals. These are like really quick problems to factor, but they still require factoring, okay? So what the pattern is, first of all, what does it mean to be a difference of squares? Well, number 1, it has to be a binomial. Write this down. Carter, close your computer. Has to be a binomial. Has to be a difference, which means what sign has to be in between your 2 terms? A minus sign. If it's a plus sign, it ain't going to work. And then number 3, each coefficient, each number has to be a perfect square. That is why it is called a difference of squares. Okay? What are our perfect squares? Okay, let's go in order. What is 1 squared? 1. What is 2 squared? What is 3 squared? 4 squared. 5 squared. 36. We'll stop there in my list. But these are the numbers. I don't know if there's anything bigger than, oh, you got a 125. Well, I'm going to go GCF there. Okay? So you're looking for these guys being the coefficients. And if you're in that situation, it's a binomial, has to have an x squared, with a difference, and then the coefficients are these perfect squares, then you can follow this pattern. Okay? And the way that the pattern works out is that you end up with your two factors end up being exactly the same. The first term and the second term are identical. But one has a plus and one has a minus. And that's why this ends up being a binomial. Because what happens if you were to multiply it all the way out, you would have a situation where you'd have like plus 6x minus 6x. And that's why they drop. Okay? So this is a pattern. If you don't trust me and want further explanation, I'll be happy to give you further explanation. But for now, let me show you how you can do this really quickly in your head. Okay? So, number 7, I have x squared minus 4. Remember, this is a coefficient of 1. You don't have to write that, but I just want you to recognize that still is one of our perfect squares. It's 2 terms. Check. There's a minus sign in between. Check. 1 is a perfect square. X squared is a perfect square. 4 is a perfect square. So, is this a DOS? Yes, that's what I usually write with those. Difference of squares. Okay? Is there a GCF that I can take out between 1 and 4 other than 1? Because that doesn't change anything. No. Can I take out an X in this problem? No. So I've exhausted checking for GCFs, but now I recognize that this is a difference of squares. So here I go. What is the square root of x squared? X plus, what is the square root of 4? 2. And then my other factor is going to be square root of x squared minus square root of 4. And then you're done. It's fully factored. And you don't have to go through the whole spiel that we're about to go over in the next couple of pages because it just is going to factor this every time. Square root plus square root minus square root, finished. That's why this is fast. Now you have to recognize it. Okay, let's do 8 real quick. 25x squared minus 49. Is it a DOS? Yes, because it's a binomial, it's a difference, 25, 49. Do we have a GCF here? No, we don't. So what's the square root of 25x squared? 5 what? X. Is it okay if you put the minus 1 first? Sure. Square root of 49? So then my other factor is... And you can do whichever order. I normally do the plus first, but I just want to show you could do minus first. Let's look at 10 real quick. 18x squared minus 8. Okay, I'm thinking DOS because I'm seeing binomial, I'm seeing minus, but are 18 and 8 in my list? No, but do 18 and 8 have a GCF? Was there a GCF? 2. So when I take out a 2, I'm left with 9x squared minus... Now, is this guy a DOS? Yes. 9 and 4 are in my list. So what's my final factorization?
3x plus 2, 3x plus 8.
Don't forget the GCF at the beginning. That's got to drop. 2 times square root of 9x squared is 3x plus square root of 4 is 2. Other one is 3x minus 2. So you just got to make sure you check for those GCFs first. I think there is a... 12's a little tricky because 164, they are both in my list, aren't they? But do 164 have a GCF as well? I would take that out first so that way you can get your fully factored form. And that's the thing is your instructions on this are always going to say factor completely. So if you don't take the GCF out here, you're going to give me a factor that says 10x plus 8. Is 10x plus 8 completely factored? No. So always check for GCF first. A couple of these have them, a couple of them don't. Okay? What is the GCF between 100 and 64? 4. 4. Okay? So I'll do this one, and I want you to try the other ones real quick. And then know that, like, this is a factoring pattern that you will see a lot this year. Okay? And it's easy. Don't make it harder than it needs to be. So this will be 25x squared. Again, with these, taking out that GCF is first is going to be pretty important. I did work this. I know it's really squeezed. Sorry, there's not a whole lot of space. I did work number 12 as if I didn't take the GCF out at the beginning, I'd be getting 10x minus 8, 10x plus 8. Each of those separately had a GCF of 2. If you take out like multiple GCFs from factors, you have to multiply those together. So technically you could still catch it at the very end and get the right answer, but I just always say, like, just check for GCF first, like every single time, do that, and it should work out. And then, yeah, don't forget that 1's a perfect square. Like, for instance, number 9, sometimes people will look at that and be like, I don't know. Okay, yeah, you do. Square root of 1 is 1, okay? Another thing people do, I got 2 more things that people do. Sometimes I get tripped up on the fact that there is a minus in between, and they say, like, I can't take, Miss McCartney, I can't take the square root of negative 25. Can you take the square root of negative 25?
Yes.
Negative 25? No, not today, but you can in a few weeks. But it has to be a minus sign in there for this pattern to work. So don't harp on the fact that this is a negative 25. The minus has to be there. Just square root the numbers separately, and you're good to go. This is quick, okay? Now let me show you a problem. I'm going to write in this space right here. Tell me the difference between, what should I do? Well, we'll go back to this one. 4x squared minus 4x versus 4x squared minus 4. Because we put this on stuff before, and people miss it.
The top is factoring GCF and the bottom is difference squared.
Very good. The top factoring is GCF. Is this a difference of squares here? 4x squared minus 4x. Is that a DOS? Difference of squares? No. All you can do is take out a GCF. Finished. It's number 5. Okay? What about 4x squared minus 4 with no x on it? Is that a DOS? Difference of squares. Yes, it does have a GCF. It is this problem right here, number 11. So you really got to be careful. With binomials, like if it's a difference of squares, it's got to be something perfect square minus perfect square with like no x on it. Okay? Because we put that on there before, and yeah, people miss it. So don't get lazy. Don't work too fast and make mistakes. Okay? Questions about binomial factoring with GCFs or the pattern yet? All right, make sure we're awake. Make sure your thinking caps are on. We are going to switch to page 17 we'll actually go to 16 for just a second. Okay? We're going to come back to 7 through 12. We're going to come back to that, but I'm skipping that for a reason, so just hang with me. You know there's a method to my madness usually. We're going to start here at the bottom where it says factoring trinomials. Okay? How many terms is a trinomial? 3 terms. This is what you're going to see most of the time. Binomials are great. Factoring binomials I do in my process of factoring trinomials, but typically you're going to start with your trinomial. So we need to make sure we get there. Who learned it the box way in middle school? Okay? You are welcome to use the box. I personally hate the box, but I'm not going to count off on your paper if you can get the right answer from the box. To me, it just takes too much time, and I don't really like that much time. I do this little X thing. I just don't like boxing, but that's just me. So I'm not saying that you can't use the box. Are we all clear on that?
Yep.
Okay? This is the method that I use, and I'm going to, anytime I do factoring in this class, which how often are we going to do factoring? A lot. I always do factoring by grouping. So I'm going to star this one. This is my favorite. Okay. This is the way I teach it in Algebra 1. And like for once the past couple of years, like our kids have left Algebra 1 and they can freaking factor. Okay. So I'm a big fan of this method. Yeah, this is what I do. You also do have to learn factoring by grouping when we get to factoring higher level polynomials. So you're gonna have to learn it at some point, okay? So this is the method that I do. You can look through that. That's great. I'm gonna do steps over here on this page. And then there's also this method that our other two advanced algebra teachers really like called slide and divide. I don't teach it that way. It just, I don't know. I can't explain like why it works. Therefore, that's just not the way that I teach it because I kind of think it's a little bit of a shortcut. But there's examples of that if you would like to use it again. I'm not going to mark something wrong as long as you have work to back it up. Now, if you just like have a bunch of answers and nothing on your paper, I'm going to question where you got your answers from. But I'm going to do factor by grouping. And that's just my favorite, and you're in my class, so welcome. All right, here are our steps when we factor by grouping. And a lot of the methods kind of have the same similar steps. So like either whatever way you choose, like pick your poison, you're going to be doing the same idea. So step number 1, we always check for a GCF. Check for GCF. If we have one, we take it out. It's going to make our factoring life easier. So we always need to check for it, okay? If you don't have one, move on. There's a lot of times you will, a lot of times you won't. Check for a GCF. Step number 2, I call it the number puzzle. I do an X. Who knows CAB? Makes a little table and does C times A and then B, whatever. It's all the same thing. Okay, if you don't know what I'm talking about, just wait a minute, do it my way. Okay, but I'm figuring out my 2 numbers that win my little puzzle have to do 2 specific things. I'll get to that. Just write this down for now. Here's where grouping gets a little bit different. Everyone's method, you got to start with these. Grouping gets a little bit different in step 3. Step 3, I'm going to kind of write up here in case I run out of room. After I get my 2 winning numbers, I'm going to write my trinomial, which is in 3 terms. I'm going to write it in 4 terms. Okay, so write the polynomial in 4 terms. My number puzzle is going to help me figure out how to break it to go from a trinomial to a 4-term polynomial. Okay, so that's why we have to do that number puzzle. And then from there, when I have 4 terms, I'm able to make 2 groups. Okay, that's why it's called factor by grouping. So step 4, I'm going to group and factor. Bless you. And then step 5, I'm able to write in factored form. Who's seen factor by grouping before? Okay. So you probably kind of know what I'm talking about. And if you don't, just write it down. It will all make sense after a few examples. Okay? But I really I've taught, the only factoring method I haven't taught is slide and divide, but I've taught like other ones, and this is my favorite. And it's been my favorite for a long time. Okay? And it's so important. Okay? Are you ready? We're going to try to knock out a couple of these. Yes? We'll get ready because it's happening. All right. Number 13. 18x squared plus 33x minus 30. Let's go through my checklist. Do I have a GCF?
3.
Yes. What is it? 3. Okay? You always want to take out your GCF, especially when you're doing stuff non-calculator. Simplifying your coefficients is going to make your mental math life way better. Okay? So take out the 3. What's left when I divide out the 3?
6x squared.
6x squared. Okay, there's a lot of mumbling, but I think we were right in there. Okay, here's what I do with my GCF, because after I take it out at the beginning, I do not need that GCF until my final answer. So I'm going to drop it down and ignore it for a while. I'm going to put it on my answer blank, because don't forget it. That drives me crazy. If you take it out, just put it on your answer blank, which is going to be down here, and then ignore it for a minute. Are we okay? And I'm focused solely on this trinomial that's left over. And now the coefficients are a lot simpler. Remember, in standard form, this is not in standard form, but when you look at your simplified trinomial, the coefficient in front of x squared is your a, then your b, then your c. So this is where that CAB thing comes from, because I'm going to talk about these in terms of like a is the coefficient on x squared, b is the coefficient on x, and c is the constant, okay? It's not in standard form anymore because I took out the 3, but I can still I'm focusing just on this guy right now, okay? So here's the number puzzle. This is the way I do it. If you are a CAB person, CAB, or just make a table or whatever you do, we got to figure out the two numbers that do two things. So I do a little x over here. Who's seen the x before? I think a lot of middle school teachers have been doing this for a while, okay? So at the top of my x, I need to find my product between my a term and my c term, okay? So I need to multiply the first, and again, I'm ignoring the GCF at the beginning. I need to multiply the first coefficient times the last number. A lot of times in Algebra 1, we say, oh, we make a little rainbow right there. So what is 6 times negative 10? Negative 60. So that's my product, okay? A times C. I'm looking for numbers that multiply to be negative 60. There's a lot. But there's only one pair of numbers that also sums to be B, the middle term, with the sign. So I'm going to put positive 11 at the bottom. Okay? Yeah. Do you have the answers? Okay, hold on for just a second. Some of y'all can number puzzle like so fast, and I think that is amazing. Some people take a little bit longer, so let's try not to always blurt out the answers. And also, if you do take a little longer, that's okay. Mental math is hard for me too, and I'm a math teacher. Okay, so you'll get it. So you have to go through and you have to think of two numbers that do two things. They have to multiply to be negative 60, but they also have to add to be positive 11. That is the puzzle. Okay, Will, help us out. 15 and negative 4 is correct.
Oh,
Can't be 5 and 6.
negative 60.
Would it be 5 and 6 is
God.
5 and 6 and
Negative
that's
5
fancy.
and 6 would be.
I always start with the factors of the top. There's going to be a lot less numbers that multiply to be 60 than add to be 11. Okay? So these are our number puzzle winners right here. Okay? No matter what factoring method you do, you're going to have to do this. And this is the hardest part, in my opinion. This is the hardest part, is figuring out these two winners. Okay, are you still with me? Here's where grouping gets a little bit different. Step 3 is to take my polynomial, which again is in 3, and I'm going to write it in 4. So here's what I'm going to do. My two number puzzle winners really need to have x's by them, and I'm going to split that 11x into 15x minus 4x, because what is 15x minus 4x? It's still 11x, so I am not changing the value of my polynomial. I'm just being creative in writing it a different way. Okay? Are we all okay with that? So now that I have my 4 terms, now I'm ready to group since I have even groups here. So where is a sticky note? Because I like to teach kids with that. Oops. Okay, so I am going to group my first 2 terms and my last 2 terms. And I'm even going to cover up my first 2 terms. And guess what kind of problem this is? The same type of problem that you just did at the beginning. A binomial, take out a GCF. So what can I take out of 6x squared and 15x? 3 what? 3x. And when I take that out, what's left in?
2x plus 5.
2x, 6x squared divided by 3x is 2x. 15x divided by 3x is 5. So it turns into just like a little binomial that you're just GCFing, okay? On the other side, my group, be careful here, this guy is negative. If that third term is negative, then you are going to take out a negative. What can I take out of 4 and 10? 4x and 10.
Negative 2.
Negative 2. Careful with the signs. Negative 4x divided by negative 2 is? Negative 10 divided by negative 2 is? 5.
Who would have thought that?
Okay? Here's what should happen. Should happen if you do grouping right. What do you notice about what I just highlighted that didn't show up on this one? They are the same. If they are not the same, did you group correctly? No. Now, your final factored form, the parentheses that was left over when you took out your GCFs, that makes up one of your factors. So here's my answer blank. I have my GCF drop down. I have my matching. 2x plus 5 is a factor. What's the other factor?
3x minus 2.
3x minus 2.
That's kind of easy.
It's a process. It's not terribly hard to do. It is just a process. There's a lot of thinking. There's a lot of room for error. Here is my most favorite thing about grouping. If you put, all right, Will helped us out, and he said my number puzzle was 15 and negative 4. What if you put 6x squared minus 4x plus 15x minus 10? Is that going to mess up your answer?
No, it's the same thing.
No. So even if your work looks a little bit different, what will happen is that what's in the parentheses here is going to be the other factor, and then your GCFs will be on the outside. So I think this is the best method of doing it. Yes, it's a process. Boo-hoo. It's all a process. You have to know how to do it. Okay? Let's talk through, I'm going to talk through 14, and I want you guys to try these too. Okay? This page right here is the most intense. I know I skipped a page, but there's a shortcut to that. Okay? All right. If you got it, rock and roll. If you still want to watch me do this process one more time, I'm going to talk through 14. We're doing great. All right. Do I have a GCF here? No, but do I have to check for it? Yes. No GCF. Okay, move on. Number puzzle it. So what goes at the top of your number puzzle? A times C. 4 times 9 is 36. What goes at the bottom of your puzzle? What kind of 12? Positive. Be careful with that. That sign is really important.
I know the answer.
Okay?
I know
Pause.
them. I know them.
Pause. Pause.
How did you get to?
I know the solution.
How did I get to what?
Oh, wait, no, I said it.
All right. Number puzzle. What is it?
6 and 6.
6 and 6.
I knew the solution.
And I'm going to go ahead and put an X right there. Okay, now I'm going to 4 terms. You always keep your squared term the same. You split the middle term into your number puzzles. Now, these 2 number puzzle winners are the exact same. Something crazy is going to happen. Not really crazy, but something, because they are the same, you'll see what happens here. Okay, and then you bring down the last number as well. When you group this, you guys, the first group, you will always take out an X at minimum. Every single time, that first group is going to have an X squared and an X. So you can always take out an X. Sometimes you can take out a number with it. So 4X squared and 6X, what can we take out? 2X. And what's left in, when I divide that out? 2X plus 3. Now, your second group, you can only take out a number. And I kind of talked about this sign right here. If that third term, whatever type of number that is, positive or negative, that tells you the type of number you're going to take out. So since this is a positive 6X, I'm taking out a positive number. On this problem, this was a negative 4X, so I knew I had to take out a negative number. What can I take out between 6X and 9?
Yo, that is
Yo, it's the same thing. Yo, exactly. But you put 2x plus 3 squared.
No, you only put it one time.
Well, no, you asked for x plus 3.
Oh,
X plus 3, like the
okay,
final
yes. So, your factors that match, you write one time. Your GCFs in front, you write one time. But what happens on this problem? They were the exact same. They were matching. That's because of this situation, you guys. That's going to happen there. So, if you see that situation, yeah, you can probably get there faster. So you can write this as 2x plus 3 quantity squared. Would I count it wrong if you wrote them side by side? No. But this is a little more simplified there.
So, see, like, it's always confused me. So you're not really getting the solution. You're just writing it a different way.
No. Okay. That's a good question. Are we solving anything?
No, you're not solving.
No.
It's just like
We are factoring.
like why?
Yes. Because we're going to get to solving. And this is a method to solve, but we're just not there yet.
So there's like this and then more steps to it?
Very easy steps. Way easier than this. But yes. Okay? All right. I want you to try 15 and 16. You check. Okay? What about number 15? Was there a GCF? No. What was the number puzzle winners on 15? -6, +4. What's your final answer? X minus 2 and 3x plus 4. Or I did 3x plus 4, x minus 2. Is that okay?
Yes, I think so.
Absolutely. Okay? You can write whichever factor you want to first. Okay? This one wasn't too bad. Now, there was a negative on the bottom. I don't think we've seen that yet. Make sure that you take that sign with it, because if you miss that, then again, your signs are going to be backwards on your number puzzle. So that's really important. Just details. Just a lot of details. Okay, 16. There was a GCF. You can see right there it is 2. Your number puzzle. Okay, if you didn't take that GCF out, your number puzzle was even worse. But if you did take the GCF out, you had -240 at the top, and then you had 1 at the bottom. So that's kind of what I was talking about. To get a negative number on the top, one of your winners on the puzzle has to be negative. The other one has to be positive. If the bottom number is 1 or -1, again, number sense says if I get a sum of positive or -1, that means the two numbers I'm adding are going to be 1 apart from each other. So that should help you kind of reason through. And those winning numbers are +16, -15. Okay? So then you group those. Don't forget to bring your GCF all the way down to the bottom. I literally, every time I do a GCF, I arrow all the way down, put it there. You don't put it on your test, points off. So don't do that. And then here's your factors. The only order that I'm picky about, GCFs, which are monomials, need to be in the very front. Okay, I want that first, and then your binomial factors can be next. Okay, all right, flip back over to 7 through 12. I want you to, where am I? I want you to do problem 7 by grouping real quick.
Number 11?
Number 7.
Oh,
Sorry, I heard you.
that is the incorrect number, actually. But
Okay, is there a GCF on number 7? No. Your number puzzle, what is it? Hold on, what goes at the top of your number puzzle? Close your Chromebook. What goes at the top of your? 12. What goes at the bottom?
7.
What are the winners? 4 and 3. Okay, so when I do grouping, I'm going to write this in 4 terms. X squared plus 4x plus 3x plus 12. And then I'm going to group x squared plus 4x. What can I take out? And what's left in? 3x plus 12, I'm taking out a positive. What's my GCF there? What's left? What's my final factored form? X plus 3, x plus 4. Okay, here's my question for you. What do you notice about your number puzzle winners and your factors here?
Oh my gosh.
oh my goodness.
Wow.
Oh.
They are the
insane.
same.
I
Okay?
don't see it.
What?
4 and 3. 4 and 3.
Oh my gosh, did you get it?
Oh, well, yeah.
Okay, but did that hold true for this one? -6 and +4. What is the difference between the problems here and the problems here?
GCF or
Positives and negatives.
What is the A value on all this section? 1. What was the A value on all of that section? Not 1. Okay? So,
Where's the N?
I call this the front number. The front number. I call this easy factoring. And I'm going to say this all year. What defines something as being easy factoring, according to me, your teacher, is that the A value is 1. If your A value is not 1, you have to do the whole shebang, the whole grouping, the 4 terms, the yada, 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 whatever method you are doing. If it is A value is 1, once you get the number puzzle, just take those numbers and slide them into factors. So it's a lot faster. But here's what I need you to understand. Look at me. Look at me right now. The only time you can do the shortcut is if the A value is
Positive.
1. It is not going to work if it is 2, 3, 4, 5, 50, anything that is not 1. Yes.
Actually, no. It's an obvious question.
Yep, nope.
Yeah, it'll always be just X plus within the things, right?
Yeah, and the reason why is when your A value is 1, the only way you can get to x squared is by multiplying x times x. And so that's why those numbers right there, they just slide in. Now, if you had like a 6x, you don't know, is it 6 and 1? Is it 2 and 3? You got to do the whole game, okay? But for this situation, so let's try 8 together, and I'm going to have you try these. And again, these should be quick. Yes?
Okay, I'm kind of confused. So it's x plus 4 and x plus 4. How do we get x plus 3 and then x plus 4?
Because this is not your final answer. This is just the grouping. Your GCFs are taken out. These two factors are identical, so you are factoring it out one time, and that leaves you with the GCFs in the front.
What font?
It's the same thing we just did on the whole back page.
How about a 2?
Why do you have to solve them when you can literally
Easy
just
done.
like
You can. You don't have to group that. From here on this, the rest of this page, you don't have to group. Okay.
Well, I'll still do it anyway.
That's fine. And some people like say I have to do the whole method over and over again. Let me come over there in a second. Okay? No, you can't skip all the steps. You still have to do the number puzzle. You can skip 3, 4, 5.
Literally what she said.
Literally.
Okay. Okay, literally, stop talking. What is the top number here? On number 8. Watch me. Hush.
Negative 15.
-15. What's the bottom number on number 8?
-2.
Watch that sign. You've got to make sure you get that sign. Is the A value 1? Yes. Is this quote-unquote easy factoring? Yes. What are the winners in my number puzzle? 2 numbers that multiply, hold it, multiply to be -15, add to be -2. What are they? -5, +3. Watch. Because the A value is 1, because this is easy factoring, I am able to put x minus 5 as a factor, x plus 3 is my other factor, and I am done. It's only when A is 1. Okay? That's what I'm saying. Okay, do the next ones. I will finish 9 through 12. Again, all those are A values being 1, so it is kind of, you can use the shortcut. The only reason why we can use the shortcut is because A is 1. Okay? There is, just so you know, I will put an answer key to page 18 on Canvas. I will put an answer key to page 18. I'm okay if you go to your 4.3 practice and work on that since that's a required practice. But if you're struggling, we need to really work on this here. The only thing I'm going to say is page 18, you're actually getting into the converting. So to convert to factored form, y'all, we've been doing it. You just factor. It's just you're going to actually have an equation now. So instead of just writing your side-by-side factors, you're going to be writing y equals your side-by-side factors. Do you see the difference? That's like actually what we're getting to. So your homework is going to be that way as well. Can I borrow this for a second? It's going to say here, you're going to do 4.4, converting to factored form. So I'm trying not to show all your work. It's a lot. There's a mixture of difference of squares. There's a mixture of GCF. There's a mixture of easy factoring, hard factoring. 28 is kind of a thinker. You might want to think about how to do 28. Sure is. Okay? So I'll get an answer key to the rest of this, but I want you to get working on your homework. Guys, on your homework is worded like it is on page 18. You have to convert, and when you convert, make sure you are putting y equals on all of those on your homework. Okay? Because you're getting to that factored form. So you need the y equals. If you don't put the y equals on the test, I'm taking off points, and you're not going to like that. Okay, I'm going to work out page 18.